Hello students, in this video we are looking at solving and graphing inequalities in one variable, and I wanted to remind you of the order that we were solving equations in. This order is still going to be what we're going through. We'll first clear fractions, simplify one or both sides, looking for the variable on both sides, seeing if there's anything left next to the variable and getting rid of each of those either by addition and subtraction or multiplication or division. And then now we're ready for this one here at the bottom. Did I multiply or divide by a negative? If your answer is yes, flip the symbol, box your answer. If your answer is no, you are done, box your answer. So let us look at some examples here. First off, we will look at the golden rule. Whenever you multiply or divide both sides of an inequality by a negative number, you must flip the inequality symbol. So here we have an example. 5 minus 3x is less than or equal to 13 plus x. Well, first off, let us look at things that would be open or closed. Less than, greater than, not equal to. These are all things that have an open circle. Less than or equal to, greater than or equal to, and equal to are things that when we graph have a closed circle. So with equations, when we solved those, we would end up with x equaling one number. And then if we were going to graph it, you would just put a point on the line and then you would be done. But with inequalities, you have a whole host of numbers that could be your solution. So let us go ahead and solve this equation. First off, we're going to go ahead and get rid of, well, let's just go through. We don't have any fractions to clear. We don't need to simplify either side, but we do have a variable on both sides. So what we're going to do is, for this one, we're going to go ahead and get rid of this positive x by subtracting x from both sides, so that with the inequality we have the x on the left-hand side. So we'll simplify here and we'll get 5 minus 4x is less than or equal to 13 because the positive x and the negative x zeroed out. Next, is there anything next to my variable? On the same side with my variable, I have a negative 4 being multiplied by the x, and I have a 5 that's being added. So can I add or subtract to get rid of one of those? I can subtract 5 from both sides, leaving negative 4x is less than or equal to 8. My next question is, can I multiply or divide to get that x by itself? I can. I can divide by a negative 4. So that gives me an x here. This gives me a negative 2 here. And now the last question. Did I multiply or divide by a negative number? I did. So this right here is going to tell me to flip the inequality symbol. So instead of being less than or equal to, I am now greater than or equal to. Because it's a greater than or equal to, I'm going to have a closed circle, and because it's greater than, I'm going to shade to the right. Let's put the negative 2 in the middle. I put a closed circle at negative 2, and then I shade over this direction to the right because these are all the things that are bigger than negative 2. Okay, we have a couple of more examples here. So on this example on the left, negative 4 multiplied by the quantity x plus 8 minus 2 is less than 20. I don't have any fractions to take care of, but I do need to distribute here, and then I'll need to combine like terms. So I get negative 4x minus 32 minus 2 is less than 20. Negative 32 and negative 2 are like terms, so I get negative 4x negative 4x minus 34 is less than 20. So now both sides are simplified. Is the variable on both sides? It is not. Is there anything next to my variable? Yes, I have a negative 4 and a negative 34. I can get rid of the negative 34 by adding 34 to both sides. These zero out. I'm left with negative 4x is less than 54. At this point, I need to get rid of this negative 4. So I will divide both sides by a negative 4. Those cancel out. I have an x here. And if you use your calculator, you can take that, go to alpha y equals, and you can take the negative 54 over 4, simplify that fraction, and that is going to give you negative 27 over 2. Now that's going to be a little difficult, so we'll go ahead and do the negative 27 divided by 2 to get a decimal. That might be a little bit easier to graph. So then there's negative 13.5, so this would be negative 12.5. Over here this would be negative 14.5, and so this would be negative 15, or sorry, negative 14. Oh, I did it right the first time. Negative 12, negative 12 and a half, negative 13, negative 13 and a half, negative 14, negative 14 and a half, negative 15. Tried to talk myself out of that there. So it's negative 14, negative 13, and negative 12 for those others. But right here, I divided by a negative, so this less than becomes greater than. So negative 27 and a half is negative 13 halves, so I'm going to use an open circle. And because I want greater than, I'm going to shade to the right. So this is x is greater than negative 13.5. That might be easier for some of you on the number line. The last example is negative 5 times the quantity x minus 2 is greater than 2 minus x. So we don't have any fractions to clear, but we do need to simplify. So we get negative 5x plus 10 is greater than 2 minus x. For inequalities, it would be nice to have them on the left-hand side, but I do want to show you about the flip-flopping and about the order mattering. So I'm going to go ahead and take care of this positive 5x, or adding 5x to both sides, because that'll get rid of the negative 5x. So we get 10 is greater than 2 minus 4, plus 4x. Get rid of the 2 on both sides. So we have 8 is greater than 4x, and here we will divide both sides by 4, and we get 2 is greater than x. But this is a situation like we had seen in a previous video. I need to get the x on this side and the 2 on this side. Notice how the open part is towards the 2 and the pointy part is towards the x. So I'll put that pointy part there and spread it out. If 2 is bigger than x, that means that x is smaller than 2. So here we have a strictly less than. So strictly less than is an open circle. Put an open circle at 2, and we want things smaller, so that shades to the left. Okay, and so this is solving and graphing inequalities in one variable. So it doesn't really matter. Back up here we could have gotten rid of the negative 3x, but at the end we still would have had to done some sort of a flip-flop. Here we needed to flip the sides so that the x is on the left so that we can tell which direction we're going to go. And that should get you through. And if you need to, you don't like the fraction, go ahead and turn it into a decimal and try to find that decimal on the number line.